Welcome everyone to this RapidPipeline Twin Studio webinar. This is the second webinar in the series, and the first one was hosted by Eric Chadwick, our senior 3D artist. So you can find that first webinar from, I think, about 2 weeks ago on our YouTube channel. And this is the second part in the series where we are looking at some updates on the Twin Studio side in comparison to last time. We will basically go over a quick reintroduction to the tool. What does it do? Where are we coming from? What is RapidPipeline also developing outside of Twin Studio? And then basically just going through a quick demo session, quick workflow from importing a parametric CAD asset and then getting out an exported real-time ready file and a rendering, doing some material assignments, doing automatic UV unwrapping, just basically some of the steps, vertical slice of what Twin Studio can do and can deliver for you. Yeah, when going from parametric CAD data to something which is visualization ready, something which can be shared with marketing departments, for example, to create the perfect shot for your product. So 2 quick words on me. I'm Julian. I'm co-founder and head of 3D solutions at DGG. I'm with the company from the beginning since about 8 years. And yeah, my background's a bit mixed in basically real-time graphics, video games, and XR, but then also mixed in with applied research and basically doing 3D data acquisition and basically 3D scans and so on. And then over the years, I also took over now basically the relationship between the customers on our end, including the industrial customers, and also talking to our engineers, doing roadmap planning and so on, basically funneling in the features we get from our customers to our engineering team and being up to date with the industry, doing performance analysis, case studies, and so on. Yeah. By the way, at any time in this webinar, you can ask questions. So we have our Q&A system active, and we have a couple stuff in the background to also answer your questions. So feel free to bombard me. I will take the time at the end of this webinar to also go myself through a couple open questions. So at the beginning, just a quick recap for the ones of you who are new and never heard about us. So RapidPipeline started as a complete customizable 3D processing LOD creation optimization tool. So it was really focused more on the real-time downstream pipeline at the beginning of our existence. Parts of our team also helped defining the GLTF standard, for example, if you know that. So basically the portable 3D standard, render everything everywhere. It's a slogan there. And we were also involved in certain aspects of WebGL and at least on the usability side. And this is basically where we are originally coming from. And since almost 2 years now, we are also very much involved in CAD processing and how to get basically parametric 3D data inside the tooling. So that's a very different approach from just working on a tessellated, working on a kind of 3D model type of thing with triangles and quads and so on. The whole CAD ingestion is a complete new world where you basically have to convert the freeform shapes basically and solids into actual triangulated data via tessellation. So we did a lot of work to be able to automatically do that in a graceful way, but then leaving the options also to tessellate in a finer resolution, really adjusting the settings of the tessellation, doing cleanup operations on CAD import and so on, to really give the user the power to process the CAD files in the best possible way and fitting their specific workflow, of course. During all our processing, we are always trying to be as much up to date with any open standards. So we are not having an internal black box format in a way, at least not a 3D format or like a custom CAD format or something, but we're really working on open standards. And I think that's a good segue for the next slide here. Throughout all our products, and we're not only having Twin Studio, as I said before, we also have plugins for a lot of the basically most popular DCC tools on the market, for example, from Autodesk, Max and Maya, then Blender, of course, Unreal Engine, as well as Substance Painter in this case. We also have a web tool and we have a CLI tool more on the enterprise side, like a complete headless automation tool, which runs basically our core processing, our 3D features, which is basically also shipped as a component, like an ingestion component here in all these applications. For some of these plugins, we are using specific file formats for exchange at the moment. In some, it's GLTF because it's just super rigid and standardized and easy to exchange with. With a bit older tools such as Max and Maya, we of course exchanging with their kind of native desired FBX specification. That actually includes materials. So in Max, it's physical material. In Maya, it's out of their standard material. So these, for the most part, these materials are also supported in the interchange process, which is a bit a standout in terms of file interchange, I would say, compared to other tools. But the most up-to-date tool we have, Twin Studio, is basically completely running on USD, which is evolving as the exchange standard, I would say, for 3D files these days. And it's already up there for a couple of years now, but it's a really cool format, really promising, and you can do a lot with it. It's a bit more than just a 3D format for the folks who know about it. It can also be used as a runtime, for example. Yeah. And if you have any questions about any of the plugins, just let us know. We basically, in the offering, even when you get a trial for our desktop license, which includes all of these, basically your seat, which you have, even the test seat you get, you can switch between all these tools. So there's no separate licensing for just 3ds Max or something like that. We don't do that. It's one software, it runs on different interfaces, and you're paying just for that one software, basically. Yeah, today's topics. So we're quickly going through a CAD import process into Twin Studio. What is that about? How does that work? What settings are there on that end? In that sense, we're also looking at tessellation resolution, comparing a little bit what we can do there. We're looking at model cleanup operations. So for example, filling up solid holes and recalculating mesh normals and things like that. Culling operations we can also perform. So small feature culling, if you have a little small screws in your file, or just small parts you don't want to have, you can cull them out by specifying kind of the exact size of them or in percentage to the whole asset. Occlusion culling, basically raycasting based approach. And then we have, of course, material assignment. So I'll talk through that a bit in detail later. Then super new feature we have is the rendering in Twin Studio. As Twin Studio in general is still in beta, it's an ever evolving process, let's say, and we're super happy to get your feedback on that. But yeah, we have a first iteration on actual rendering. If I'm not mistaken, it's path traced rendering, and you can already save out image files. So it's a bit bare bones, but it's already a proof of concept, and we are constantly developing on top of that. Yeah, we're also covering a little bit automation. So what are we planning, at least also in Twin Studio, to have for automation, and what other automation options exist within RapidPipeline's offering? And then basically we're going about a few optimization tasks, which is another part of Twin Studio as well, where we can perform some decimation, some even remeshing, baking of materials and so on. And yeah, at the end, exporting to, for example, web-ready formats like GLTF. That rounds up the demo. And again, at the end, I'm trying to get some more Q&A going, but yeah, please feel free to ask questions at any point. Yeah, basically just a quick foreshadowing before I'm showing it live on the tessellation resolution. I think that's one of our first topics. Let me see if I can just use those as kind of topic slides. I think that makes the most sense. Yeah, so instead of just running you through this boring slide deck, I will just continue with the app itself. And so the first operation we're basically looking at is part of the CAD import. And that will be, of course, the tessellation resolution. And we have a small update here as well. So I hope this session will be also very interesting for people who are already familiar with RapidPipeline Twin Studio. So I have a file here imported. So just that you get a better feeling for it. Let me see if I can maybe just import another file, like just a very simple box. And once you started the import process, you basically get a little dialog window, and you can choose between import 3D CAD format or 3D file format. The difference here is that on the 3D file format tab, you have a few more settings which are really relevant for any type of, let's say, normal polygonal 3D format. So for example, for USD, you can select the purpose here, a few of the kind of settings. How should Twin Studio interpret the file coming in? But today it's more about the CAD format import, and here the interesting stuff is in the tessellation settings, for example. So we offer basically tessellation presets, so a little bit what you've seen on the slides here. When we go from an extra fine to an extra coarse tessellation resolution, usually we do not recommend anything lower than medium. There might be use cases where you want to just see if the file actually is supported, and then we would recommend just to see, okay, can I load this file and use extra coarse, or do you want to check something quickly? if it's a very complicated assembly, that is maybe an option. Or if you really want to base your LODs on these low tessellation resolutions. But in general, because we have a pretty powerful decimation tool, we would recommend to also basically import on a more higher tessellation resolution. We can always go lower with mesh decimation later, and it will look better than, for example, the coarse or extra coarse resolutions here. The reason for that is that the decimation actually keeps the angle and tries to not facet the asset in a way, tries to not downgrade basically the curvature of the shapes. And that actually happens with the lower resolution of the tessellation by design. Our recommendation is for quick import, medium. For more advanced or like more detailed needs, go with fine or extra fine if you're using the presets. What we also have is a custom resolution here, and then you can actually work with the max surface deviation, angle, and edge length settings. These are actually perfectly well explained also in our more detailed documentation. So here just a screenshot from our documentation, how this behaves. So I think the main attribute you guys are looking at when you have a custom resolution is your surface deviation. So that's basically your quality setting. And by default, it's 0.4. That roughly corresponds to like a medium tessellation. But if you really want to go a bit more detailed, something like 0.05 or 0.01 is recommended. The max angle really basically restricts how deep fillets and corners are tessellated. We recommend to leave it at the default of 40. If you limit that, you might get also a bit low resolution on your fillets, which you probably don't want if you want a really visualization-ready, accurate representation. Then we have max edge length. This can help if you have a really like a cylinder shape or something, and it's really stretched out and you have long, thin triangles probably, or maybe quads, and I'm getting to the quads topic in a bit. Then you can basically build in edge loops. This works quite well. You can set that up. For this demo session, I'm not using it, but yeah, you can experiment a bit with it. It's not a perfect feature, but in most of the time it inserts basically an edge loop where you would expect it, given the correct input shape. And then we have a few other settings here which can help with the import process as well. We have a removal of T-junctions. So the setting says it removes T-junctions, but it actually adds at the end smaller, higher vertex count, because when it sees a T-junction, so basically, let me see if I can pull this up in our documentation really quickly. You see here. So in this case, it would actually add additional geometry, right? So it would add here another, basically an edge connecting the two closest vertices of this face to basically being able to fix that T-junction. So at the end, it says remove T-junction, but at the end, it actually adds on your vertex count, which is marginal. It's not too big, but it really helps avoiding T-junctions on the asset. And that already happens on the tessellation step on import. So that's always great to have checked. Sometimes on the CAD tools, you come from like a Z-up orientation. As we are more like a traditional 3D background, we set up the Twin Studio on a Y-up. So you can basically convert from your CAD orientation to the 3D model orientation. And I think Eric Chadwick explained that really in a great way in the first webinar, that it might stem from the fact that on the CAD side, you basically have, if you start in 2D, you're starting basically on the ground, and then basically your Y is basically with X and Y are on the ground floor, and then Z goes up. And programs more on the polygonal 3D, they were orienting more on a kind of I think a movie screen. That was what he was talking about. And then you basically have Y pointing actually up, and then X to the side, and then Z would be also on the in 3D on the ground dimension. So that's the difference here. But yeah, having that checked, usually you know where your CAD file is coming from. That also helps with batch processing, of course. And then you can check that if that file is coming from this particular CAD format and exported with the Z-up orientation, for example. We have fixed winding order here, so I can demonstrate that a little bit as well. That is an automatic process, and we can do that later, at a later stage as well. It's part of the cleanup mesh operation we have in the tool, but you already can do that as a cleanup process on import. And the same is true for removing of occluded parts. So that's also available as a separate function. So I'm not checking these right now, and basically just importing the file now, and it will be replacing the notebook I had here. And yeah, as you can see, very simple example model. So maybe one thing you can realize here is basically an update we have since this version, that's version 0.9.3. And that is that we on import, always try to quadrify the tessellation. So for certain parts that works really well, especially with rounded corners, borders, and fillets. For certain parts, it's not that visible, as you can maybe see here on the outer side. But overall, Twin Studio always tries to retain quads, and that's also something we will continue to improve. And maybe that's more visible on other models, for example. But yeah, it's a great thing to have. And as of now, any operation you will run on the geometry, of course, if you do a decimation, then of course you will not have quads anymore, but triangles. But yeah, we're looking at that at the moment as well to retain the quads, improve the quads, and then retain the quads as much as possible. If you ask why quads for CAD files, I don't want to do a squishy Pixar style animation on it. So why would I even need that in the first place? So what we found, and that was a lot of customer feedback as well, is that it might help later on if you're doing certain manual operations on a file, that you're easier able to select edge loops, and you can basically identify certain problems with the model quicker if you do like a manual roundup. So I think that's the main, and happy to hear your guys' opinions and questions on this. But that's the gist of what we got from the user feedback, that, hey, quads, yeah, on a hard surface asset, actually maybe not needed, but it's really cool to have them just to be able to work a bit in a more simple way. A lot of 3D tools have issues identifying edge loops if you have triangle soups. It's technically also pretty arbitrary, not easy to do. And with quads, that's a lot easier. So yeah, that's one of the aspects why we support it. And basically this was now in a custom resolution. So if I'm going to the import tab again, just to demonstrate it, I'm going on the same box asset, open, and now I will just do the extra coarse preset just to see what changes. And it should definitely reduce the resolution by a lot. So as you can see here, it's still the box, you can still see it, but it's not really, especially if you go in the shaded view, for example, and you look at the shape of the boreholes here. Yeah, this is not necessarily a resolution you ever want for your visualization. So yeah, but the import was pretty quick and easy. So that's a benefit here. Right. Yeah, so let me continue with the winding order correction. So that's an interesting one. We have a new option here in our viewport to look at face orientation. So it will render everything in blue. And basically, if you zoom in and go between the faces, any back faces here, these ones, for example, they are now rendered in red. So this is a cool check to see, hey, it's not that important for render visualization, path tracing, etc. But once your pipeline ever goes real time, and or you have a rasterizer where you have backface culling enabled, for example, in a WebGL based viewer or something, having winding order issues is then of course really detrimental, because then yeah, your model is half open, you have split faces in a visual way. So to make sure you don't have these issues, this might also be relevant for game engines as well. So if you're going to Unreal or so later, it would be just best case scenario to completely avoid winding order problems entirely. So let me see if I can quickly demo this with another asset. So we have a robot arm here, which I will just convert with the default settings. And I'm purposefully not fixing the winding order right now, just that I see it right now because I didn't talk about it. One very important setting, and this actually applies to this robot model here, is the sewing of the B-reps. So it's the setting is called CAD sewing tolerance. And we have this by default in millimeter set on to 0.05. We highly recommend to keep this as it is, and highly recommend to not set it to 0 unless you want to retain the different parts of the fillets and overall structure of the CAD file in terms of patches. If you really want all these patches, and usually that will tank any type of software due to just the sheer amount of draw calls, basically you want this to always perform the sewing. The cool thing is it doesn't sew or stitch together actually vertices or something. It actually sews together the border parts and patches of on the B-rep, on the boundary representation of the actual parametric data, and then sends this information to the tessellation, so that the tessellation then actually creates this one merged edge, let's say, from the beginning, instead of having two separate patches. Let me see if I can just, before we go further, demonstrate this a little bit. We have a new GitHub repo, which is using our automation tooling, but it's a really cool thing to see also to get some sample assets for testing in case you don't have any CAD files at hand. And basically what you can see here with the sample model I'm actually getting at, it comes into out of the parametric data with all these different parts, which are called patches. And this also leads to problems, of course, in winding order and a lot of further issues. So ideally, these parts are merged already on the parametric side. And this is exactly what we're doing here automatically. So let me just get this file. And on import now we have the swing. And this is a cool example because now we don't have these single phase problems with the model, with the version of this model which would have been imported without the swing. Now that we have the swing, we have these great different parts. So if I'm going back in the shaded view, I can actually see, oh, these are actual coherent parts in terms of what happened on the swing side. So we highly recommend having this feature enabled. But if we go back to the phase orientation, we see, oh, now we have a whole part of the model which is flipped basically. And that is not a problem at all. We can go in our mesh cleanup operation. We can basically, see if I can disable the recomputation of normals. We don't want to have that happening here at the moment. We just want the winding order fix, right? And what it actually does, if I'm now running the software, and this was pretty fast, so now we have it corrected. But what it actually does is multiple things at once. So it actually starts raycasting and checks against where the sky is. So this winding order check will also work with assets which are basically stacked into each other. So you have multiple layers of visibility, and it will figure out which side is outside, which side is inside. There are more settings, also even more settings in our automation tooling, which can be exposed as well, which can fine tune this process in terms of, do you want to make that calculation per mesh? Do you even want to make that calculation per mesh lump of the scene? Do you want to make a general calculation of all the files in the scene together? So there's really a lot of fine tuning possible. But right now, the action is pretty straightforward and flips per mesh lump, actually. So it calculates all the triangles of the scene, which direction should they go. And then as an after step, it checks, okay, for the whole mesh lump, what's the ratio between triangles which are supposed to show one way versus the other way? And then it cleans up or let's say it harmonizes the triangle order per mesh lump. So at the end, it doesn't really matter if it's a single triangle, if it's a whole part which has incorrect winding order. It will deal with any types of these issues generally. Yeah. Let me go back to shaded view. And as you can see in the shaded view, you never saw any of that. And that's usually true for a lot of 3D tooling where you don't have a specific mode open. So in Blender, there is a specific mode which renders a bit similar, where you have the flipped faces indicated in red. And basically, in a lot of other tools, I think Substance Stager is one where you usually don't ever see that happening. So this is a bit of a tricky cleanup, let's say. But with Twin Studio, you basically what the deal is with that, and you can always check it up with the face orientation shaded face orientation view mode. Yeah, so let's try to go a bit faster here because I think I'm already a bit behind time. So on the removal of occluded parts, so that's another cool feature. This works actually pretty similar to the winding order tool. So where it basically uses a raycasting approach again and checks for visibility of parts. And for that, let me just import very quickly another model. That is our demo drill in a variance. Let me see if I can pull up this one. And one important aspect is, I believe this is the up. I'm trying to correct it here. And let's go just for a preset this time, just to put more in a simple way. And here we go. You can also see in contrast to the robot arm here, we actually have a few materials from CAD, which is really cool. And that's basically almost the next step. I can show you guys how to basically automate parts of the material assignment in a way. So basically what we have here is that drill file, and let me just blend out this node, and you can see here in black is all this like a cable running, some batteries down here. So there's a lot of interior stuff going on. And in order to just remove that, it's as simple as just using the remove occluded parts action, which is already here. I could have used it on import, but yeah, I just want to show you a couple of the settings here inside the actual operation to better illustrate what it actually does. So we have a culling quality. For most parts, you're fine with the default quality, and it's a good ratio between processing time and actually getting the result. You can also do the culling per mesh. In this case, this would probably result in not much triangles, or at the end, not much parts removed, because it basically would just isolate each of the meshes and then does the visibility check. Yeah, usually the best is to do the visibility check for the whole model. If your scene equals the whole model, then this is what you want to do. So you leave that unchecked. You can do ignore transparency. This is usually relevant for not necessarily CAD files, but when you already assigned a material somewhere and it has transparencies, or you import a non-CAD file, like a 3D file from Max, Maya, etc., Blender, which has transparency set up, alpha blending, and so on, then actually that is recognized and it can ignore the transparency. So by default, it doesn't do that, meaning if this handle would be transparent, like it is in the slide here on the right side, if that would be actually the material, if this is a fictional translucent plastic drill, then it actually would not remove them because it realizes this material is transparent, so the inner parts are supposed to be visible. So that's a really cool feature, but it is dependent on the materiality, so it won't just work for something you declare as invisible without the proper material. The visibility per part, it's a bit similar to what I explained right now with the winding order. So it basically will not leave behind single triangles. So if you turn this off, it will really just check per triangle, or in this case per quad. Let me double check if that imported actually correctly. Wireframe on surface. So yeah, we have a few quads here, especially on the rounded parts. So it would compute per triangle / quad here. And then you would probably have kind of what we would call a triangle soup inside, because maybe some of these faces are visible through some of these angles here, because we have a few through holes where we could potentially, from a certain angle, when we cast a ray here, see parts of the interior. So what you usually want is visibility per part, and that is not to be confused with per mesh. So a mesh can be basically something like this node here, but this node could, in theory, and that's the legal 3D thing, have different mesh lumps, so non-connected triangulated parts basically, or quad parts, like, and they're together, they could form one mesh, but that doesn't mean that these are all connected necessarily. So what the per part thing does is that it actually recognizes that there are mesh lumps in meshes. And I think in Maya, you could call this shape as a concept. But yeah, so that basically just makes sure, hey, we're not doing this just on a per triangle basis. And then we have a visibility threshold on the triangle basis, which is by default set to 10% in this case, and that is usually enough. So basically, if the asset is 90% or more invisible, basically the per lump, so each mesh lump has 90% or more triangles invisible, then we decide this for the whole mesh lump, just to be very clean, and flip or remove the whole part instead of just per triangle. So that's just a metric for that, but it's also a bit more in detail explained in the documentation. So yeah, if we just run the complete defaults on this model as an entirety, you can see also the progress bar here that it does the visibility computation. And now we should technically get rid of at least most of the interior parts. There is an option, and you can see the black part here. We actually can see from the outside on one of these inner tubes from this black material, and that's why that one, for example, is not removed. But let me just double check that I didn't tell you anything wrong here. It seems like that the cable actually was somehow visible a little bit from one of these holes, so that is actually not removed. If you encounter things like that, this is more like a feature rather than a bug, as it really casts a lot of rays and sees that from any angle, is this really invisible? You can actually manage to remove these by playing around a bit with the culling quality and the visibility threshold, right? So if you say, hey, this cable was maybe visible to all triangles of this cable were maybe visible to, let's say, only maybe 20%, right? Then changing your visibility threshold usually covers that as well. But yeah, usually this is the correct way, and you don't necessarily want to cull things which are in any case somehow visible. But again, yeah, you can always adjust that and remove more or less of the parts as well. Yeah, we have normal computation. Let me double check if I can demo that actually in the app. So let me see if I have the right file here. Yeah, I don't have the correct file here right now, but basically what you can do with normal recomputation is if you have an issue with actual mesh normals, you can basically recompute them on import and fix certain issues you might have. So I'm not sure if the drill is the correct example here. Let me just double check on the other files just to see. Yeah, let me go with the robot and fix the winding order on import directly. And I will use it just for demonstration purposes. So I will try to break the normals, not in a computational way, but in a visual way a little bit, and then fix them again with the cleanup operation. And I'm sorry for that. I was apparently not prepared with the right example for this action. So basically what you can see here, the normals look fine. They actually look correct. Let me remove the exposure a little bit because we have the white material here. And basically what we could do is we say, hey, we force recompute the normals on this file and let's set the angle. And right now we have it set on area. So depending on your asset, area or angle computation method might be better. And yeah, that the details about that is also explained in our documentation, what to use. By default is area and works usually best for general models with flat surfaces, like you can see here. But let's choose an angle like 60%. So that would basically decide between hard edge and soft edge. And my expectation now would be if I run this on this file to basically get quite ugly soft edges. So as you can see here, in theory, this works great if you have a really smooth, nice tessellated model. If you know from video game production, or maybe video game is not really the right industry, but let's say for animated movies, right, where you have just quads and you're doing like really cool subdivision workflows and stuff. They're having the soft shading, which is achieved by setting this, for example, to 60 degrees or higher. Basically, usually ends up with kind of a cool, kind of somewhat beveled look here. But as you can see for CAD models, especially with interesting tessellation paradigms, let's say, you really have not a great shading. And if you encounter anything like that, and it happens that these normals are stored in a, let's say, wrong way, or there's something going wrong on the file interchange level coming out of any DCC tool, for example, this can happen. And to easily fix that, basically for CAD files, we recommend an angle of 30 degrees and the computation method area, for example, and then basically rerunning this again. And as you can see here, the 30 degrees did the trick for this type of asset. And from our experience, does the trick for most of the CAD files we've seen so far. But you really only need this if your model's mesh normals are actually really broken or really wrong and you want to try something else. So that works as well. And as always, you can always go back and forth through history. So I can go all the way back here to the different state of the process. All right. Yeah, let me quickly jump into the next few sections, and then we'll continue with a few overview of a few features which are still in development, and then trying to get the QI going as well. So don't have much time left. So in Twin Studio, we just covered basically the input process and what we call the model section, where you actually have some of the model actions, cleanup operations, things like that, what you've seen before. There's an example for, let me see if I can just get this to work, for defeaturing of holes. Let me see. Yeah, let me import a little bit more complex asset, but let me give it a medium resolution so you guys don't wait too long here for the import, because that model is actually the one I prepared also for material assignment, which is a really cool topic as well, which we will jump in. And then I can also quickly demonstrate other model features, which are quite new, such as defeaturing of solid holes. This is a highly requested feature. And we now have it also in Twin Studio with this version. So this file is a bit larger. So all the files I imported so far were on the CAD side between 3 and 5, maybe 10 megabyte. This one is 250, I think, 220, 250, something like that. So it has quite a lot of data inside for a test demo asset. So it's not really representative, I would say, of a more like professional industry assembly, which is also something we can load and operate on, of course, but it's far more complex than these other examples we've seen here. And these models are actually, as I said before, also linked in our new GitHub repo, which I can also share the link at some point. So in this case, it has quite an assembly tree, and quite some challenges with it. As you can see here as well, it really requires the patch suing as well. Otherwise you get way too many parts. So let's see how this works. Should load any minute. Worst case, I will just showcase this on a simpler model. But yeah, it should load any time. Yeah, it's already converting to quartz, loading the stage. Perfect. So for a minute, I thought that's it. This webinar didn't work out, but yeah, I tested this before. Yeah, this is a great model. It has a lot of components for, as I said, for a demo asset. It has a lot of hidden parts. It's still fairly simple in its shapes, fairly primitive oriented, but it's a really cool hobbyist example, let's say, to look at some operations here from our end. So what I wanted to show before is you can see we have some through holes and some bore holes. Actually, these are all through holes on our asset. And with that featuring solid holes action, for example, we can get rid of them, as you can see here. And if we do a normal cleanup in this case, as it's a very new feature, we should run that on the whole asset and get basically very flat, even surfaces, which we can then use, for example, for a decimation process. So as you can see here, it removed almost all the holes on the flat sides. I think the current restriction on the holes is that they have to be circular. So that's something we're looking at to improve. And these holes here on the side, they're not perfectly circular, they're a little bit elliptic. So that's actually something we're looking at the moment to improve, of course, and even give you maybe additional setting if that's possible to define how circular a hole has to be. And yeah, this is basically one of our first defeaturing settings, and there will be more to come. So also looking at other shapes of holes, of course. But as you can see, this is not just a simple, hey, this is a surface hole, right, on one side of the mesh and just a broken topology and fill that gap in, but it actually closes the geometry and leaves no trace behind, let's say, in that regard. And then we have a good basis to basically decimate on that surface and make it really lower resolution compared to what we could do without the hole closing. Yeah, let me just, out of sake of time, we of course have to fill surface holes as well. So if you have actually stuff which needs to be beveled in a way or needs to be closed, we have a function for that as well. In that iteration, also scanning basically for circular holes. So right now this won't work on quadratic holes or any other shapes, but that's definitely something we will work on for the next version update. Yeah, and basically, let's come to the actual meats and potatoes, let's say, of Twin Studio, where you actually can go into the materials tab. And what you can do is you can identify the imported materials here on the right side, including the scene graph. And on the left side, you can basically connect to a material library. Right now, this is, I think, the NVIDIA physical materials, also based on Material X and OpenPBR, if I'm not mistaken. And this is just a sample library to play around with. The actual plan for, I think, one of the next updates of Twin Studio is to also be able to load other materials and basically increase a little bit the variety of existing materials. So for now, this is basically the only set we can deal with, but very soon we are offering a lot more connectors basically. And the ideal goal, the vision here is that you can bring your own material library, and then if it's open standards, and you might be able to look into how convert existing material libraries. Yeah, but just being able basically to bring your own materials into the app, that's the ultimate goal. And the cool thing is what you can do here on the fly is you can just drag and drop a material and then replace a CAD material with it, and it will basically replace the whole material tree for all these models and parts. And you can see that this material technically has a texture, it has a roughness map, everything with it, but it's not really reflected on this model. And of course, the reason is that we don't have UVs assigned, but that's actually pretty easy. It's actually pretty simple. So we can just basically do, for example, a cube unwrapping here. So basically a box mapping, and you can just do it on a right click per part. And then basically now, oh wonder, we have actually basically a mapping. We can see the texture, can go on the UV mode as well to see what we did here. So no other part has UVs except for the ones we just selected. And as you can see with this more complex file, let me see if I can go back before I assigned that. It's a bit tedious to do this for all parts. That's also a feature we're looking at the moment, to basically select multiple parts, doing operations only on selected parts. Right now, it always does, as you could see, the operations on the whole model, but that's already planned for the next update to actually have a more fine-grained control here. And what we can do for now, which is pretty cool, is scene graph flattening. So we can do this, for example, by material. And let's just run this whole asset through this pipeline. And what it now does, it will merge the actual nodes to the material. So now we have one mesh node here for the whole associated material. And now it's way more smoother to just do the cube unwrapping. Now we can do this with one click. And of course, as I said before, we want to make this type of workflow work also without performing the flattening. But this is also, yeah, a cool feature. Flattening, of course, saves a lot on draw calls as well. And as you can see in the UV view, we actually managed to do this fairly quickly. If we go in the material tab and do the same thing again, we're identifying the material, replacing it, deselecting it, and now we have the cool pattern from our texture already on it. So that's great. Now, basically, one thing we could do is also render the model. And let me see if I can just go back a little bit. Perfect. Okay, so I went all the way back. And so that's a cool thing. I think that's one big improvement, that we also went and cleaned up a few issues we had on the history. So before, it was not that stable, I think, in the first alpha and the very first beta releases. And now that should run already a lot more stable, as you can see here, with a more or less medium, let's say medium complex assembly. And yeah, basically what we can do now, let me see and go ahead, do the process very quickly again of the scene graph flattening by material, just that we can process it. Perfect. So now in the UV view, we're basically doing our unwrapping again, or in this case, just the projection mapping. And in the material tab, we're doing the same workflow again by replacing our material here. And one new feature, and I know we're running out of time, but I just wanted to show it as a cool showcase, is our new path traced renderer. So that's now built in. And we're actually also working on getting you other industry standard path tracers from a lot of different providers into the app. And basically on the little record button here, this is how it works at the moment. You can save out your render file, your image, sorry. And I already have one here. Let's call it number 2. Save it out. And basically then if you go into your scene structure, you see, all right, in the render folder here, I saved out the rendering right now, which is on purpose with an alpha background, which is cool. So you can actually use that rendering then and maybe even ingest it into a workflow, generating a background for your model or something. That is maybe also something I didn't talk about, that the main purpose of Twin Studio is to generate these white studio shots of your product. And then you can actually use these rendered results with the alpha background, or you can also use the 3D model itself and render it somewhere else, for example, because it has open standard materials and open standard formats. You can save out a USD, pretty simple. And then basically generate a background for it. Try to run it in through more like a Gen AI workflow. But we are, of course, strong believers that on the 3D level, you want to be as accurate as possible. So you really want to start with a rendering like this, or like the prepared 3D asset like this. And then only from there, you can add some environment props, some lighting, and so on top of that. But the accuracy of your product, of your original CAD file, of course, is non-negotiable, as it's set in the context of digital twin or digital rendering twin buzzword at the moment. All right, and at the end, we have the optimize section where you have basically the same interface as in the model section. The only difference is you have really cool downstream optimization workflows here where you can actually create automatically a UV atlas, for example, and then bake texture maps, bake normal maps, do this all automated. That whole section is a little bit coming from basically the inception of RapidPipeline originally, where we're coming from originally, which is downstream 3D optimization. And you have a lot of options here. There will be more to come in terms of integration as well. But yeah, so just to demo a little bit, we have right now, I think, 3 million triangles resolution. So I can show this a little bit on the wireframe, on surface as well. And on the decimation side, let's try here to go maybe to something like 800K or so. could also be less or more. We also have a deviation percentage here, which is cool, which automatically decides the error between the input and output surfaces. So you can actually use that for batching over a larger database of files, and it will give a smaller resolution to simple shapes, like say a pillow or something, and then it will give a higher resolution automatically towards like a CAD assembly or something, which is more complicated. And then you can top this with a cap. So you can say, hey, my face target is X and my deviation target is Y. If you decide this mesh would need 50 million resolution, please cut this off and give me 5 million instead, or 1 million, or in this case, 800K, and just let me deal with it basically. So if we just run it through, we get the output with the specified face count in this case, probably because the deviation percentage is set like 0.01%. So it's really stay very, if possible, close to the input surface, meaning the calculated optimal resolution for this file might be like 2 million or faces or something. This is at least what I'm expecting right now. And that's why it will hit into the face target of 800K. Yeah. As it's a large file, you can see it's processing at the moment, and we get the output. Two additional things to decimation is it actually has the option to preserve topology, which by default is off. This works pretty well if you don't decimate a lot, but if you want to decimate really a high amount, we recommend turning this off because it's just a constraint on the decimation actually. And having preserved mesh normals on is something we recommend. It's also on by default. Which is pretty cool. So we don't need to do any normal recalculation here, what other tools probably need to do. And as you could see from before, a normal recalculation is always a little bit risky, depending on what asset you have. And yeah, this case doesn't need it. It preserves the input mesh normals as good as possible, even when we're decimating quite a bit. And then basically what it does as well is UV preservation. So in this case, we already have the UVs here. Let me see if that was even how it deals with that in terms of preserving the existing UVs. So we should still see the material assigned even with the textures. Let's see how that comes out. So it should be done now. And I think we are also at time. So once this is done, any second now, I'll also quickly switch to the questions. I think it's decimating here again. So that's one thing which can happen, that it tries to decimate again, especially if you use a deviation target, that it says, okay, I need to recalculate the deviation. I couldn't hit the target or something. Actually, we also have a built-in safeguard basically. So if a mesh would completely break, it will actually tell you in the command log that it tries to rerun it with a slightly smaller, higher target than you set. But this usually appears only in very rare cases. And I think in this case, because I already assigned UVs, so the recommended workflow is to first do a decimation if you really know where to go and you need to go downstream, for example, and then create the UVs, assign the materials and so on. But yeah, usually should work both sides. So now we actually have a result. That's cool. It's quite low resolution, but we should still technically see the materials. Yeah, we still see all the materials applied. But keep in mind, we reduced now with the actual UVs assigned already. So that's always a big constraint on a decimation process. And yeah, in most cases, we recommend the other way around, decimating first and then we do the assignment in the UVs. But in any case, that's only true for this decimator. So in case you're doing the remeasure or you're doing a complete independent decimation with baking of materials, then this all what I said before now is irrelevant. I was more talking about the specific decimate mesh operation here. And then you can basically just bake downstream from the materials you have and everything you set up in Twin Studio. And then as a last step, of course, you can go ahead and save this out, export as a file format. And you can do it as a USD, right, to not really lose any fidelity, but you can also go with the GLB file format, for example, and then just save that out and then render it in any web viewer, render it almost everywhere, right? Like formats like GLTF, GLB are available almost everywhere. So let me see. Yeah, quickly running through, operations by part selection. That's something for the next update. Industry standard renderer integration is also on the list. And then general improvements. For example, what I just showed, the file export right now is quite limited, right? You just export to a file, and we're working on getting you more settings there, which we already have. We're building them into Twin Studio as well, where you can do some more mesh compression, some texture compression, and a lot more settings on the export side as well. All right, I think we have 7 answered. That's great. yeah, other than that, we have a lot of new exciting features, and I'm really looking forward already to the next webinar, which is probably done by Eric Chadwick, to show you even more updates and hopefully also some more updates on the feature requests you guys have. Thank you very much, and have a great week.